We're going to look at this problem, which is very similar to the last one, with some very small changes, and we're going to see why it requires completely different analysis and makes the whole problem completely different. It says, after taking some criticism from their study design, the disc golfers tried a new approach. Each player throws 10 discs with one technique and 10 discs with the other technique. There were 8 volunteer players. The order of which technique comes first is randomized for each player. Again, they still want to prove that throwing forehand will work better. Now, the key thing here is that each player throws 10 with one technique and 10 with the other. So that means that each player is actually in both treatment groups. Now, obviously, they can't do it at exactly the same time, but overall, they'll do one of them first. It says the order of which one comes first is randomized, so they'll do one of these first, backhand maybe, and then do the forehand. Other people will do them in reverse order. Quick side note, the reason why you'd want to randomize the order and not just have everyone do backhand and then everyone do forehand is perhaps the order that you do them in actually affects your results or biases the results one way or another. Maybe you do better on the second one, making forehand potentially look better than it really was. So let's jump into the questions. First one says the explanatory variable in this scenario and what are the treatment options. The two different techniques are going to be your explanatory variable because it's going to explain how well you do. And so those techniques are backhand or forehand. B says what is measured for each individual, aka what is the response variable, and then is it quantitative or categorical. The response is going to be how well they do, and in this case it says they each throw 10 discs with each technique, so it's how many discs they successfully make out of the 10. So maybe 7 out of 10 or 9 out of 10, 3 out of 10, so forth. So the number of successes or makes out of 10 is the response variable. And a number out of 10 is going to be quantitative, not categorical. It says if it is quantitative, are there matched pairs or two distinct samples? And this is the part that makes everything change. We said that we have one player right here throw with both techniques. One player is in both treatment groups, and that is what makes it a matched pairs scenario. There are not two distinct groups. As a result then, the type of interval or test that you're going to perform in StatKey is going to be a test of a single mean. We'll take a look at that in StatKey in a second. In order to have a single mean, you need to have a single list of numbers. And right down here, you can see that we have 2 lists of numbers along with our player IDs. And we need to get this down to a single list. So the way that we're going to do that is we're going to subtract. Now, if you want to go forehand minus backhand, or if you want to go backhand minus forehand, that is completely up to you. It says here that we're trying to prove that forehand is better, which leads me to believe that if we do forehand minus backhand, we'll end up with more positive numbers. So I personally am going to choose to do forehand minus backhand for each of these. The important part is that you're consistent. You pick one way of doing it, it doesn't actually matter which one, and then you're consistent with it. So for player number 1, they do 2 better with their forehand than their backhand, so we draw a 2. For the next player, it looks like they actually do 1 worse with their forehand than their backhand, so forehand minus backhand would be -1. And so forth all the way across. And sometimes you're going to have larger numbers, sometimes they're going to come out to be exactly the same. 4 and 4 with each technique, so you get a difference of 0. And so you keep going until you have all of your data, and this is your list of data that you plug into StatKey. You take this list of 8 numbers and you plug it into the test of a single mean. So if we hop into StatKey here, we're looking for our interval and our test of a single mean, and they're right up here, just like you would do with any standard one variable data. We're going to start with the hypothesis test. We go to edit our data, and we can remove all of the data in there initially, and then we fill it in with our numbers, 2, -1, 3, and so forth. Once you have all of your data typed in correctly here, you hit OK. And the next thing we need to do is deal with our null hypothesis. So we'll go back to the problems before we talk about that one. It says, what is the null hypothesis in this scenario? Use the correct symbols or subscripts so it is clear what each symbol means. The null hypothesis always represents that there is no difference between the groups. And when we have matched pairs like we do here, no difference would mean something like player number 5, where the two treatments are exactly the same. It doesn't matter what group you're in, the difference is going to be 0. Now, the null then would be that the average of all of these, even if there's some higher and some lower, is going to be 0 every single time. And so if we go ahead and set mu equal to 0, the average of this list of differences here comes out to nothing. We have to make sure we give a little subscript to what that mu really stands for. It stands for forehand minus backhand. So you could write out forehand minus backhand, or if f minus b is clear enough as a subscript, you can use that. But there's a single mean. There's not mu f equals mu b. It is a single mean. If you said mu of b minus f equals 0, that would also be correct, because no matter which way you subtract, the difference should be 0 if the two groups are equal. And then it says, what is the alternative hypothesis? The alternative follows naturally from your null. So it is the exact same thing you have as your null. Mu of f minus b is something compared to 0. And remember, our options are always greater than, less than, or not equal. And so the deciding whether it's going to be which one of those three, it depends on the problem, depends on what you're actually looking to prove. It says the order of which techniques come first is randomized. Again, they still want to prove that throwing forehand will work better. So they're predicting that the forehands are going to do better than the backhands. So that means the numbers for the forehands should be bigger than the numbers for the backhands. And then in this case, since our average here represents forehand minus backhand, if the forehands are bigger, forehand minus backhand is going to be a positive number. It's going to be greater than 0. If I had redone this problem and I decided that mu was going to be backhand minus forehand equals 0, then it would be mu of backhand minus forehand is less than 0. It would change my alternative hypothesis, because each of these numbers would all have be the opposite of what they are. Next part says, what is the p-value of your test? And to do that, we go back into StatKey where we edited our data, put it in just a moment ago. We set our null to mu is equal to 0. Remember, mu is equal to 0. This is a good place to always remember your null if you forget it. It does say it right up here. And once we have that set, we can start generating a whole bunch of data. And we expect that if we have no difference, that we're going to see most of the data come up around 0 in the middle. However, our actual difference between the two groups, if we took the average of all those numbers we made, would be 1.625. So if I'm going to try to figure that out on here, I'll just start with the two-tail for a moment. We're going to change that, but I'm going to set my high end up here to 1.625. I have to compare it to my original sample. Once I type that in, it's going to adjust, slide this over a little bit. Now, right now I have it set up for an alternative of a two-tail test. But we said here that it's going to be greater than 0 as our alternative, greater than 0. And if it's greater than 0, it means my alternative, I'm looking on the right tail. I'm just going to go with the right tail. I'm actually going to get rid of the two-tail. And here I have a p-value then up top of 0.017. So my p-value, if I had to write it down, it's going to be 0.017. Now, what to do with a p-value of that? It's less than 0.05, so we know it's statistically significant. It means that we've rejected the null. It says, is this an observational study or an experiment? An experiment, we always know, is trying to figure out what causes what. And there shouldn't be any lurking variables when you run an experiment. Now, since every person is trying both treatments, in theory the two people, or the person in each treatment should be exactly the same. And so there should be very few lurking variables in a matched pairs test. The order could be a lurking variable, doing one first or doing the other first, but it says that they randomized the order, so they got rid of that lurking variable. They ran the experiment on 8 different people, so it's not just one person they're testing, they actually ran it on 8 people. So far everything looks pretty good, and there are more than one treatment groups, so there is a comparison. So I would say yes, it is an experiment, a valid experiment. So based on the fact that we have an experiment, and based on the fact that we have a statistically significant p-value, what can we conclude? Well, we can conclude that the explanatory variable in fact causes the response. So we can, and looking back to our alternative here, we can say that throwing forehand causes you to do better than throwing backhand when shooting 10 shots at whatever distance they shot at. So you can actually say that the treatment did cause your success. Last part is just talking about a confidence interval here, and you can see it says what is the estimated difference between the groups, and it asks to do that at 95%. Well, it's going to work the same way as the test. You have your list of differences down here, and if we go back into StatKey, we can actually just copy and paste our old data, and then we can go back to the main screen and do the confidence interval for a single mean median. So same idea as the hypothesis test. I edit my data, select all and delete, and paste it in. And now I have my data inside. I generated a whole bunch of samples to get my curve. And I can see my sample mean is pretty much near the middle here. I want to do the 95% interval, so I throw the two-tail on there, and I take the middle 95%. And it looks like my middle 95% is somewhere between 0 and 3.125. The important part for actually interpreting this, which we'll do in a moment, is to remember what this number stands for, what this list stands for. It stands for the average difference between the two groups. So on average, the forehand group made 1.6 more frisbees than the backhand group did. Even if it's the same people, you can still call them the different treatment groups. Now if we do an interval around that, we say, okay, well the difference is actually somewhere between 0 and 3.125 95% of the time. Now this coming out to a perfect clean 0 like this is kind of an element of luck actually. Often that's very rare to happen, so don't expect to see a 0 there necessarily. It's probably just going to be 2 regular numbers. And if we had to now explain in a sentence, let's pull up a quick template to see what that might look like. On our list here it says find and interpret a confidence interval for a matched pairs study. And so we're going to use this template right here. You're going to talk about how confident you are. You're going to focus on the average difference in the response between the two groups, and then you're going to give your interval. So in our case, we are 95% confident, we do a 95% interval, that the average difference in the number of frisbees made, that's our response, that's what we're measuring, is how many frisbees are made, between forehand and backhand, so we give our two treatment groups, is between 0 and 3.125 frisbees, because that's what we're measuring, is number of frisbees. And we have the low end of the interval of 0, the high end 3.125. So one more time, go through that. I'm 95% confident that the average difference in number of frisbees made between forehand and backhand groups is between 0 and 3.125 frisbees. Most important words in the sentence is average difference. So if you forget everything else, remember the average difference. The rest of it just needs to make logical sense and clearly communicate what you found. And that's all for this problem.